Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is our second class in week 3 of classes. And we've got 3 weeks left after this week before the Christmas break. So you still got lots of time to get your work finished and send it out to me for marking before the Christmas break begins. So just a reminder, there are 2 ways to participate in classes. So you can participate on radio by calling into our studio, or you can participate via Zoom using the link provided, or follow the instructions in your study guide. If you don't have a study guide, you can always contact your DEC or contact me to find out how to join Zoom classes. All PLAR Math students are welcome to attend classes, so it doesn't matter if you signed up for PLAR Radio Zoom or PLAR IL, you're still welcome to attend the classes if you are available at that time, or you can watch the recorded classes that are uploaded to YouTube at a later date. To contact me, you can use email, phone, or send a message on Facebook, whichever is more convenient to you. And the PLAR English classes from last term, for those of you who didn't finish, are still available on YouTube. So those classes will be there until, they'll be there for the rest of the year, but they will be updated as we start teaching new classes in the next term. So for now, if you need help with your PLAR English, you want to watch the classes again, they are available on YouTube. So you can just go there and check out the classes from last term. Just a reminder that PLAR students who didn't finish their work in Term 1A, so the English or the History Geography, you can continue working on the key questions into this term. You're not withdrawn from the course. Once you sign up for PLAR once in a school year, then you're in until the school year ends. So you don't have to reapply every term. You apply for PLAR once during the school year and that's it. Just a reminder for PLAR students, new and returning, starting this year, all PLAR students have the option of writing the culminating activity instead of doing the lessons and the key questions. So even if you have already done some work and submitted it, some of the key questions, you can still opt to write the culminating activity instead of doing the lessons. So then if you pass the culminating activity, you get your missing credits. So for example, if you try the PLAR English culminating and you pass it, then you will get your grade 9 and 10 PLAR English, one or both, depending on how many you need. And then you can move on to the next subject. So you don't have to do the lessons and the key questions if you pass the culminating. But if you're not successful with the culminating activity, then you will have to do the lessons and complete the key questions and submit them for marking. And then once that's all done, then you can try the culminating activity again after you've finished the lessons. So it's not a one-time thing. If you fail the culminating, you're done. No. If you fail the culminating, then you do the lessons and you try the culminating again. A reminder that there are 2 types of questions in your lessons. If you're doing the lessons, there are support questions and key questions. The support questions are there for you to get practice before you do the key questions. So as you read through the lesson, the support questions are scattered throughout. So you read a section, then there will be a support question. Do the support question and then go to the end of the lesson right before the key questions and you will find answers to the support questions. So after you do the support question, then flip back to the end, check your answers against the answers that are there. If you're getting most or all of the questions correct, then you move on to the key questions. The key questions are the questions that have marks. Okay, support questions don't. And all of the key questions are in a little package at the end of the lesson. So they're all stapled or attached to the end of the lesson. So you can just pull those key questions off and submit them. You don't have to pull out different pages throughout the lesson. Okay, so once you've done the support questions, work on the key questions, and you should start working on those questions as soon as you start lessons and submit them right away. don't wait to submit your questions. To submit your work, there are several different ways. First of all, you can give it to your DEC, and your DEC will send it out to us here in Sioux Lookout. If you do not have a learning center in your community, or your DEC is off or away, then you can submit your own work. Okay, there are several different ways of doing that. If you have access to a scanner at work, for example, you can scan and email your own work to studentwork@nnec.on.ca, and make sure you CC it to me as well, so that 2 people are receiving your work. And so if something happens to one email, hopefully the other email will be fine and somebody will get it. Or if you have access to a fax machine, you can fax your work to our toll-free number. Now, excuse me, if you are submitting your own work, be sure to write your name, the subject, and your teacher's name on your work. We need to know who's submitting the work so that we can return it to you. If there's no identification on the work, we can't do that. So please be sure that your name for sure is on your work when you submit it. Okay, another option for submitting your work is to use your smartphone. With your smartphone, you can either take photos of your work, or you can scan your work and then you can email it to that same address and CC it to me, or you can send it using Facebook Messenger. Okay, whatever works better for you. If you live in Sioux Lookout or the surrounding area and you come to Sioux Lookout, you can use our outdoor mailbox, which is located in the parking lot facing the post office right beside that side door. Or you can knock on the front door and give your work to whoever answers the door. And 2 other options for submitting your work: use Google Docs. So do your work using a Google Doc, and then you can share the link with me or send me the link so that I have access to your work. And you can also use Google Classroom to complete and submit your work. But Google Classroom, you can go completely paperless. Okay, so lots of options for submitting your work. Also, we have student draws at the end of every term. So at the end of this term, we will have 2 student draws, one for students who earned a credit and one for students who submit work. So for every lesson that you submit, your name gets entered into a draw for a prize, as of yet undetermined. But your name will be entered into a draw. So if you submit all 5 of your lessons, then you get 5 chances to win a prize. If you also complete the culminating activity and get your credit in that same term, your name goes into a draw for earning a credit. So you could win, you have the opportunity to win 2 prizes in one term for submitting work and for completing, for earning a credit. So keep that in mind as you're doing your work. Okay, so let's start off with a review of what we talked about in our class on Tuesday, and then we will continue on talking about fractions. So last week we started talking about what fractions are and the different types of fractions. Oh my gosh, brain fart. And then on Tuesday, we started talking about equivalent fractions and reducing fractions. So there are several reasons for reducing fractions. It's very important because when we reduce fractions, it can make doing operations with fractions a lot easier, because then we're working with the smaller numbers. Okay, so if we reduce fractions to lowest terms, then we can add, subtract, multiply, and divide with smaller numbers. So we reduce fractions before we do an operation with fractions, but we also reduce fractions for our final answer. So if when you've done your adding or subtracting, multiplying or dividing with fractions, look at your final answer and decide if it needs to be reduced. If it does, make sure you do that. So the way we reduce a fraction to lowest terms is by finding what's called an equivalent fraction. So in an equivalent fraction, the value of the fraction is the same, but the numbers are different. The numbers look different. So here we have an example of an equivalent fraction. We've got 2/4 and a half. These are equivalent fractions. They both represent the same amount. So just to draw a diagram to show you. Okay, so this first fraction is 2/4. The second one will be a half. So for 2/4, the denominator, the number on the bottom, tells me that this circle is going to be divided into 4 equal pieces. 2, the numerator on the top, tells me that 2 of those pieces are going to be shaded. Okay, so that's 2/4. For the fraction half, I'm going to divide my circle into 2 equal pieces because that's what the denominator tells me. And one of those pieces is shaded. So this is my diagram for a half and my diagram for 2/4. And you can see that the amount that's shaded in both is equal. So these are equivalent fractions. So when we reduce to lowest terms, that means that there is no number other than 1 that can be divided evenly into both the numerator and the denominator. And it's also called simplifying a fraction. So sometimes when you reduce a fraction, just like in our equivalent fractions 2/4 and a half, the number on the top will be 1. So that's called a unit fraction. So anytime you have a fraction, it doesn't matter what it is, 1/7, 1/10, 1/50th, doesn't matter how big the denominator is, if you have a 1 on the top, that means the fraction is in lowest terms. It can't get any smaller. Okay, so why do we reduce fractions to lowest terms? To make it easier to work with the fractions. So in the problem 33, and we'll get into multiplying fractions later on, but if you had to multiply 33/99 and 24/48, it would be much easier if we reduced those fractions to lowest terms. So if we had smaller numbers to work with. Otherwise, you've got to multiply 33 times 24 and 99 times 48, and then you're getting huge numbers that you have to reduce. So if we reduce before we multiply, then we're working with smaller numbers. Okay, so let's reduce a couple of fractions before we move on. So 30/60ths. So 30/60ths is kind of a special fraction. In this one, it's easy to reduce because they both have 0. So what we can do is just get rid of the zeros and reduce it to 3/6. That's one way of reducing. So the only time you can do this, though, is if the numbers end with a 0. 30, 60, 10 20ths, you can get rid of it and it reduces to a half. So that's a bit of a shortcut. We don't use that very often because it's not that common when we're reducing fractions. But, so anyway, if we do that, and this is the same thing as dividing by 10. So 30 divided by 10 is 3, 60 divided by 10 is 6, so we've got 3/6. Now, we need to look at our fraction 3/6. Can we reduce that? So if we look at it, the first thing to do is to look and see if the numerator, the 3, will divide evenly into the denominator, the 6. So 3 divided by 3, I know, is 1. And I also know that 6 will divide evenly by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So my reduced fraction for 30/60ths is 1/2. Okay, so now, instead of having to multiply or divide by 30/60ths, I can multiply or divide by half. It's smaller numbers, much easier to work with. Okay, 6/18ths. So again, first thing to ask is, will the numerator divide evenly into the denominator? Is 18 divisible by 6? And the answer is yes. They are both divisible by 6, and so remember, you have to divide the numerator and the denominator by the same number. 6 divided by 6 is 1. 18 divided by 6 is 3. Sorry. So I have reduced 6/18ths to 1/3. Okay, 45 72s. So now I've got bigger numbers. I'm looking at that and I'm not sure if anything will divide evenly into it. So there's a couple of different ways to do it that we looked at. Extend my page here. So one of the ways of doing it was to list all the factors of 45. So basically, what numbers do we multiply together to get 45? So 1 and 45, of course. Put 45 over here, which we're not going to use because if you divide by 1, you don't get anywhere. 2 won't divide evenly into 45. 3 will. 3 times 15 is 45. 4 won't. 5 will. 5 times 9 will give me 45. 6, 7, 8, and then 9. So these are my factors for 45. Now I list my factors for 72. Obviously 1 and 72, which I'm not going to use, but I put them in there anyway. 72 is divisible by 2. 2 times 36 is 72. 3, no. 4, 4, no. 5, no. 6. Okay, gotta grab my calculator to figure this out. So 72 divided by 3 is 24. So 3 and 3 times 24. Okay, I can see I'm getting some same factors there. 72 divided by 4 is 18. Oh, I'm not gonna have enough room here. Is 18. 72 I know is not divisible by 5. By 6 is 12. So 6 and 12 also goes in there. 72 divided by 7, I know that's not going to work. Doesn't give me an even number. 72 divided by 8 will give me 9. And that's it. Okay, so now I can look for my common factors. So 45 I've got 3. 72 is 3. 5 is not a common one. 9 is common to both. 15, no. 45. Okay, so I've got 2 common factors, 3 and 9. Now, one way is to take the lowest common factor, which is 3, and divide the two numbers by 3, but then I'm going to have to divide again. So what I'm going to do is I'm going to take the largest common factor, which is 9, and divide by 9. So 45, 72, divide both by 9. Okay, so 45 divided by 9 is 5. 72 divided by 9 is 8, and I'm down to 5/8. Now, I know that this can't be reduced because 5 is a prime number, which means that only 1 and 5 will divide evenly into 5. So 45 70 excuse me, 2's reduces to 5/8. Okay, and that's as low as it will go. Another way to do this, if you don't want to find all these factors, is to take the bigger number, 72, subtract the smaller number, 45. 72 take away 45 is 29, right? No, not 29. Okay, use my calculator. My brain's not working this morning. So 72 take away 45 is 27. There you go. Whoops. 27. Okay, so subtract the numbers. And we get 27. The factors of 27 are 3 and 9. And so those are the common factors that we found, 3 times 9. So again, I can divide both by 9, and I will get 5/8. Okay, so there's a couple of different methods that we looked at in class on Tuesday for reducing fractions. So if you want to go back and look at those different, so one is to divide by the least common factor. The other one is divide by the greatest common factor. You can try the way we did it first. In the first examples, numerator divided into denominator, and then you can also try it by the subtracting, the quick trick, I guess you'd call it. Okay, so that was Tuesday's class. So far in lesson 1 we've done integers, finished integers, we've talked about fractions, and we've looked at reducing fractions. So today we're going to look at adding and subtracting fractions. So in your lesson, beginning on page 22 is information on adding and subtracting fractions with like denominators. So that means that the number on the bottom is the same. Okay, and then on the bottom of that page is support question number 8. Make sure you do support question number 8 before you move on to the key question. Then on the next page is adding and subtracting fractions with unlike denominators. So unlike means that the denominators are not the same. So if the denominators are not the same, we have to find a common denominator. So go through those different methods for finding a common denominator, and then make sure you do support question number 9 before you do the key question at the end of the lesson. All right, so let's look at adding and subtracting fractions with like denominators. So the first thing when you're adding or subtracting fractions, you have to look first of all and see if the denominators are the same. In 2/13 and 5/13 we have the same denominator. So if the denominators are the same, it's pretty easy, because all you have to do then is keep the same denominator in the answer and add the numerators. 2 plus 5 equals 7, so 7/13. So to show you what it looks like in a diagram, our circles are divided into 13 equal pieces. So the first circle has 2 pink pieces. The second circle, again 13 equal pieces, has 5 pink pieces. 2 plus 5 is 7. So 7 of those 13 pieces are pink. Subtracting, same idea. Check the denominators. If the denominators are the same, then the answer is going to have the same denominator. Then all we do is subtract the numerators. 4 take away 1 is 3. So here, your diagrams, the circles are divided into 5 equal pieces. The first one has 4 pink pieces. The second one, 1/5, has 1 pink piece. So if we take 1 pink piece away from the 4 pink pieces, then we're left with 3. Okay, you may get an answer which is not in lowest terms. So even if the fractions you were adding and subtracting both were. So in the example 5/12 plus 1/12, we get the same denominator. 5/12 is lowest terms because 5 is a prime number, which means we can't reduce it. And 1, of course, is a unit fraction, so we can't reduce it. So even though both of those fractions are in lowest terms, when we add them together, 5 plus 1 is 6, and we have 6/12, that is not in lowest terms. So now we have to reduce. 6 will divide evenly into 12, so 6 divided by 6, 12 divided by 6, I get half. Okay, so that is lowest terms. So again, just to show you with the diagrams, we've got 5/12 in this first circle. If we add 1/12, or we color 1/12 pink, then we have half of the circle, or 6/12 of the circle, is pink. Okay, so again, make sure you always reduce your fractions. Okay, so let's do a little bit of practice with adding and subtracting fractions with like denominators. So number 1, we got 2/5 plus 1/5. Denominators are the same, so my answer, I've just got to add my integers, my numerators. 2 plus 1 is 3, and my denominator stays the same. Number 2, 3/6 minus 2/6, same denominator, so my answer is going to have 6 as the denominator, and I'm subtracting. 3 take away 2 is 1. Okay, 1/6. So far, lowest terms. I don't have to worry about reducing. Number 3, 2/7 plus 4/7, same denominator, so I know my denominator is going to be 7. I'm going to add my numerators. 2 plus 4 is 6. 6/7 is my answer, and that's lowest terms because the 7 is a prime number. It can't be reduced. Number 4, we've got negative 1/8 plus 2/8. Yes, that's right. You will see negative fractions and you will have to work with them. Don't forget that they are negative though. So here, same thing, still got the same denominator. So my denominator is going to be 8. I don't know if my fraction is going to be negative or positive because I haven't done my addition yet. So now, when we're adding fractions, if we're adding the numerators, we still have to follow the integer rules because this is like adding negative 1 plus 2. Okay, when we write fractions as negative numbers, generally the fraction bar, like in this example, is right, or the negative sign is right beside the bar line. Now you might see it written as negative 1/8 with a negative sign in the top, but most of the time the negative sign will be right beside the bar line. You will not see it written as negative 1/8, okay, unless both are negative. So if it's a negative 1 and a negative 8, you might see that, but you won't see it written as a positive 1 over a negative 8. Okay, that's not the right way to write that. Okay, so here we have, as I was mentioning, negative 1 plus 2. So now you got to go back to your integer rules. So negative 1 plus 2, we've got a negative plus a positive. So if the signs are different, we have to subtract the numbers. 2 take away 1 equals 1. And then look at the absolute value of the numbers. So negative 1, the absolute value is 1. 2, the absolute value is 2. So 2 is bigger, it's positive. So my answer is positive 1/8. Okay, so you will have to use your integer rules even though we're working with fractions. Number 5, 3/5 take away 1/5. So the denominator stays the same. 3 take away 1 is 2, and 2/5 is lowest terms. Number 6, 5/10 take away 4/10. Denominator stays the same. 5 take away 4 is 1. Number 7, 3/9 plus 3/9. So we've got 9 as our denominator, stays as it. 3 plus 3 is 6. Now we've got 6/9. Now this fraction I know can be reduced. 3 will divide evenly into 6 and 9. Okay, so if you wanted to, 6 and 9, 9 take away 6 equals 3. So there's the number that we divide by. 6 take away 3 is 2. 9 take away 3 is 3. So we've got 2/3 is our answer. Okay, number 8, 6/11 take away 9/11. So our denominator is going to be 11. And now we've got 6 take away 9. Okay, 6 subtract 9. So remember when we're subtracting integers, the rule is to change subtraction to addition, change the number being subtracted to its opposite, and then use the addition rule. So we've got 6 plus a negative 9. So we subtract 9, take away 6 equals 3. Now is my 3 going to be negative or positive? 6 and 9 are the absolute values. 9 is bigger than 6. 9 is negative. So our answer is going to be negative 3/11. Okay, so sometimes you're going to have to do a little bit more work. It's not just straightforward subtraction or addition. So 2/20 minus 8/20. So our denominator is going to be 20. Now we've got 2 take away 8. So using your integer rules, 2 take away 8 changes to 2 plus negative 8. Okay, 2 plus a negative 8. I subtract. 8 take away 2 will give me 6. And then look at my numbers. 2, absolute value of 2 is 2. Absolute value of negative 8 is positive 8. 8 is bigger than 2. It's negative, so my answer is negative 6/20. Now, that can be reduced. Okay, what number will divide evenly into 6 and 20? Well, 6 won't divide evenly into 20. To get 6, I multiply 2 times 3. 3 won't divide evenly into 20, but 2 will. So I'm going to divide 6 by 2 and 20 by 2. Now don't forget, it's negative 6. So negative 6 divided by 2 is negative 3, and 20 divided by 2 is 10. So my answer is negative 3/10. Number 10, I've got negative 1/7 plus 4/7. Denominator stays as 7. And now I've got negative 1 plus 4. So follow the addition rules for integers. 4 take away 1 equals 3. Look at the absolute values. 4 is bigger than 1. It's positive, so my answer is going to be positive 3/7. Okay. Okay, number 11. Now in number 11 and number 12, we have 3 integers that we're adding. Okay, doesn't matter how many you're adding or subtracting, sorry. So here our denominator is still going to be 6 because they're all 6's in the denominator's position. So now we've got 11, take away 5, take away 2. So I can change it to addition and negative, but I can just do my subtraction. 11 take away 5 is 6. 6 take away 2 is 4. So my answer is 4/6. 4/6 can be reduced because both 4 and 6 are divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So 2/3 is my answer, correct answer. The next one, we've got 7/4 plus 3/4 minus 5/4. Now I know my denominator is going to be 4. I need to, this time, add and subtract. So I'm going to start with my addition. 7 plus 3 is 10. Then I'm going to subtract. 10 take away 5 is 5. My answer is 5/4. Now, 5/4 is an improper fraction. The numerator is bigger than the denominator. So if I end up with an improper fraction in my answer, I have to change that to a mixed fraction. Okay, so 4 divides into 5 once evenly with a 1 remainder, and my denominator stays the same. So my answer is 1 1/4. Okay, or 1 1/4, not 5/4. So you always have to, when you're dealing with fractions, reduce the fraction to lowest terms. If it's an improper fraction, you must change it to a mixed number. Okay, so that's adding and subtracting fractions with like denominators. Easy. All you do is work with the numerators. Denominator stays the same. But when you add and subtract fractions with unlike denominators, you have to do extra steps because you can't just add the numerators and add the denominator. So you notice that when we were doing like fractions, the denominators were the same and we kept the same. We didn't, if it was 1/4, let's go back up here. So if with our fraction 2/5 and 1/5, we didn't go 2 plus 1 is 3, 5 plus 5 is 10. We kept the same denominator. We didn't add the denominators. So when you're adding and subtracting fractions, you can't just add the numerators together and add the denominators together. It doesn't work that way. Okay, so 1/4 take away 1/2 does not equal 0/2. I'm not doing 1 take away 1 is 0 and 4 take away 2 is 2. No, that's wrong. It's not the way you do it. So what you have to do is find a common denominator. So using equivalent fractions. So if you're asked to find the sum of 1/2 and 1/12, finding the sum means that you're going to add them. You first need to find a common denominator before you add or subtract. There are several ways of doing this. The first way is method 1 is to just multiply the two denominators together. So the denominators are 2 and 12, so we multiply 2 times 12 is 24. Then we have our common denominator. Method 2 is find the least common denominator. So we've done this already. So find, to do this, since we're not using the factors, we're finding the multiples of 2. So basically what you're doing is you're counting by 2's. Okay, so 2, 4, 6, 8, 10, 14, 16, 18, 20, 22, 24. That's for your fraction 1/2. And then for your fraction 1/12, you find the multiples of 12. So you count by 12s. Okay, so 12, 24, 36, 48, 60. So then, once we've listed the multiples, we look and see if we have anything in common. Yes, we do. 12 is the common multiple. So that means that our common denominator for the two fractions will be 12. So list the multiples, just a little bit of practice for listing multiples before we move on. So the multiples of 4 and 5, so you count by 4s and you count by 5s. So 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20, 6 times 4 is 24. That's how you count by the numbers, okay? Just multiply. Or if you can do it in your head, 4, 8, 12, 16. So what you're basically doing is adding 4 each time. Okay, so 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16, 16 plus 4 is 20, etc. Counting by 5s, just about everybody knows how to count by 5s. 5, 10, 15, 20, 25, 30, etc. Okay, so what numbers do they have in common? 20 is the number they both have in common. Okay, list the multiples of, let's do 11 and 3. So the multiples of 11 are 11, 22, 33, 44, 55, etc. Multiples of 3, count by 3s. 3, 6, 9, 12, 15, 18, 21, still nothing in common yet. 24, 27, 30, 33. Okay, so I had to go a long way before I found one that was common. But they both have 33 in common. Okay, so sometimes you might have, with one number, you might have to go a long ways, and sometimes you might not. Depends on the difference between the numbers. Okay, so that's one method, is to find the common denominator. Okay, so how to add fractions? Method 1. So finding the common denominator. So if you multiply the denominators together, 2 times 12, you get 24. So now we can't just multiply the denominators together and that's it. So we have to multiply to get each numerator over the same denominator. So if we change the denominator, we have to change the numerator. So we started off with a 1/2 and a 12th. So if we change that 2 to 24 and the 12 to 24, the 1s can't stay 1s because that will make it a whole new fraction, a completely different fraction. So we also have to change the denominator. How do we change the denominator? Well, we multiplied 2 times 12 to get 24, so we also have to multiply 1 times 12 to get, in this case, 12 over 24. Okay, so that's our equivalent fraction to a 1/2. Same thing with our 1/12 fraction. We multiply 12 by 2 to get 24, so that means we got to multiply 1 by 2 as well. So our equivalent fraction is 2 24ths. So now we've got 12 24ths plus 2 24ths. So now we have a common denominator. All we have to do is add the numerators. 12 plus 2 is 14, and 14 24ths can be reduced. Divide both by 2, we end up with 7 12ths. So some quick ways to figure out potential factors. So if a number is even, it can be divided by 2. So if your number is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, basically counting by 2s, you can divide by 2. If you can add a number's digits to equal a number that is divisible by 3, the number is divisible by 3. So we counted this before, talked about this before. So the number 96, 9 plus 6 is 15, and 1 plus 5 is 6, which is divisible by 3. Okay, so 9 plus 6 equals 15. 15 is divisible by 3, and 1 plus 5, 1 and 5, is 6, and that's divisible by 3. So any number that's divisible by 3, when you add them, the digits together, then you can divide by 3. If the number ends in a 5 or a 0, it's divisible by 5. So if your number, for example, is 30, then you can divide by 5. If your number is 105, then you can divide by 5. Okay, so if it ends in a 0 or a 5, then you can divide by 5. So those are some quick ways. All right, so how to add fractions using a second method. So the same problem, a half plus 1/12. So you can't add straight across. You can't go 1 plus 1 is 2, 2 plus 12 is 14. That would be incorrect. So first of all, find a common denominator. So this is what we already did. Okay, multiples of 2 we listed, multiples of 12 we listed. We came up with 12 as our common multiple. So now what we do is we use that 12 as our common multiple. So now we multiply to get each numerator over the same denominator. So if we change the denominator, remember we got to change the numerator as well. So our fraction 1/12 is easy because 12 is already the denominator. So we don't actually have to do anything with the 1/12. The only one we need to change is the half. Okay, so what number, to change that 2 to 12, what number do we multiply, by 2 to get 12? We multiply 6 times 2 will give us 12. So if that's the case, we have to multiply the numerator by 2, or by 6, sorry, and the denominator by 6. So that will give us 6/12. So now we can add the numerators because we have 6/12 plus 1/12. This is the fraction, remember, that didn't need to change. The first one did. So now we've got the same denominator. So the denominator stays the same. 6 plus 1 is 7. 7/12 is our answer. Can it be reduced? No, because 7 is a prime number. Can't go any smaller. Okay, how to subtract fractions? Same idea. Same thing, except you're subtracting. So you find a common denominator. So 2/3 take away 3/10. Find the least common multiple for the denominators. So multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, 27. Multiples of 10, 10, 20, 30. So our common multiple is 30. So now we need to make our 2/3 and 3/10 have the same denominator. So we multiply. So 3 times 10 gave us 30. So I've got to multiply 2 times 10, which will give me 20. So my my equivalent fraction is 20/30. So same thing down here with my second fraction. 10 times 3 gave me 30, so I've got to multiply 3 times 3. 3 times 3 is 9, 10 times 3 is 30. So now I have the same denominator. So now my answer is going to be in 30ths, and I subtract 20 take away 9 is 11. So 11/30. And reduce, the fourth step, they don't have any common factors. 11 and 3, 11 is a prime number. 30. 11 is a prime number, so it stays as 11/30. Okay, so some practice with adding and subtracting fractions with unlike denominators. So 7/4 take away 8/5. So we've got 4 and 5. We can't leave 4 and 5. We can't just subtract, so we have to find a common denominator. So this one, since the numbers are small, I'm just going to say 4 times 5, so which is 20. So my common denominator is going to be 20 for both. So if I multiply 4 times 5, that means I've got to multiply 7 times 5 as well. So 7 times 5 is 35 over 20. Take away 5 times 4 is 20. Whoops. 20. Let me erase that. And then, so if I multiply 5 times 4, I've got to multiply 8 times 4 as well. 4 times 8, or 8 times 4, is 32. So now I've got 35 over 20, take away 32 over 20. So as I said, my denominator is going to be 20. I subtract my numerators. 35 take away 32 leaves me with 3/20. So my answer is 3/20, and I can't reduce that because 3 is a prime number. Okay, number 5. Oh, sorry. Let's go down this way. Number 2. 23 halves plus 9/4. So my denominators are different, 2 and 4. I've got to find a common denominator. For this one, again, I'm just going to multiply 2 times 4 and 4 times 2. So just basically multiplying the denominators. So 2 times 4 will give me 8. 23 times 4 will give me 23 times 4 is 92 plus 4 times 2 and 9 times 2. 9 times 2 is 18. 4 times 2 is 8. So now I've got the same denominator. Now I'm adding 92 plus 18 will give me 110 over 8. Okay, so 110 over 8 is an improper fraction. The number on the top, in this case, is way bigger than the number on the bottom. So now I need to reduce. So I need to know how many times will 8 divide evenly into 110. So 8 times 10 is 80. 8 times 11 is 88. 8 times 12 is 96. And if I add another 8 to that, so that's 8 times 13 will give me 104. I can't do another 8 because that'll be 112. So 8 will divide into 110 13 times evenly. And 13 times 10 I said is 104. 110 take away 104 leaves me with 6 eighths. So 13 and 6 eighths. Now 13 and 6 eighths is my answer, but 6 eighths can be reduced because both are divisible by 2. So 13 and 6 eighths reduces to 13 and 3/4. So my final answer is 13 and 3/4. So sometimes you're going to have to do a whole lot of steps, and sometimes you might only need to do a few steps. Okay. Steps for adding and subtracting mixed fractions with unlike denominators. So if you have a mixed fraction, so a whole number plus a fraction, the first thing you have to do is convert the mixed fractions to improper fractions. So remember how we did this. So the whole number 8 times the denominator 6 plus the numerator 5. So 48 plus 5 is 53. So my 8 and 5 sixths becomes 53 sixths. And then take away, and my second fraction 3 and 2 ninths. 3 times 9 plus 2. 3 times 9 is 27 plus 2 is 29. So subtract 29 ninths. Okay? Now, I'm not finished because I still have, oops, oh, it's supposed to be green. I still have different denominators. So I still have to find a common denominator for these fractions, 6 and 9. So I know that 6 and 9, my common denominator can be 18. So 53 sixths, and I'm going to multiply both by 3 to give me my equivalent fraction. So 53 times 3 is 159 over 3 times 6 is 18. And then, so that's my first fraction. And then for my second fraction, I'm going to multiply 9 by 3 and 29 by 3. So 29 times 3 is 87 over 3 times 9 is 18. So now I have my equivalent fractions, 159 eighteenths, take away 87 eighteenths. So 159 take away 87 is 72 eighteenths. Now 72 eighteenths is an improper fraction, so I'm doing this all in one. Anyway, 72 eighteenths. So how many times will 18 divide into 72? It will divide in 4 times evenly. So 18 times 4 will give me 72. So my answer is actually a whole number. My answer is actually 4. Okay, so sometimes you might end up with an answer like that. Okay, so that brings us to key question 7, adding and subtracting fractions with like and unlike denominators. So the first 2 have like denominators, the rest of them have unlike denominators. So you have to find a common denominator before you can add or subtract. So first thing you do, oops, F-I-R-S-T. So the first thing you're going to do is find your common denominator, then you add or subtract. Okay, so that's it for our class today. Try to get that question done as soon as you can, and next week we will look at multiplying and dividing fractions. So if you have any questions, please contact me, or you can watch the class again on YouTube. Other than that, miigwech, enjoy the rest of your day and have a great week.